Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept of Simulink and how we can use Simulink in a project-based approach. And in the last tutorial, we have also seen what is an algebraic loop. So in this particular tutorial, we will be seeing what are the possible solutions that we can find for an algebraic loop, how to tackle with that. So the first thing, if we are using a fixed step solver, it is very difficult to encounter the algebraic loop problem because we do not have the flexibility of choosing the step time. Basically, the algebraic loop problem gets solved if our step time is very less. Over time, if we can increase the step time, then we can simulate the system with the existing input, like the input that we are expecting here. Then second way we can implement or to solve this is via implementing a implicit solver. So basically, if we use an implicit solver, this is the part which we will be also covering in the future tutorials, that what are the types of implicit solvers that we have. And suppose if we specifically use ODE 15S or ODE 23T, which is also a trapezoidal integrator solver. With this, we can resolve the problem because the computational complexity of high computational complexity can be handled with these type of solvers. With that, also we can also try to solve the algebraic loop problem. Another way that we implemented in our last tutorial in the model is adding a unit delay block. Basically, we are creating a difference between the signal that is coming here and that is going out from here. So initial value we given as 0. With that, we solve the problem. So this is the most common approach that usually is being used when we are trying to solve the algebraic loop problem. Again, the fourth solution could be using this different solver settings. So you can use smaller step times, so smaller steps and high tolerant solvers like ODE 15S or ODE 2050. And when you work with this type of algebraic loop, mostly we will be using the implicit solver with a smaller step time to solve this type of issues. The last approach that you can use, so if you need to have a approach which will just remove the existence of the algebraic loop that is you have modeled. So basically what you can do, you can try rebuilding your model. You can try rebuilding the mathematical expression that you have, and then with the new design, if you can avoid the creation of direct connection between the input and output, then you can avoid the algebraic loop. Basically, this is the prevention of creation of algebraic loop. It is not the solution exactly, but this way you can avoid your algebraic loop creation, and that way you can solve the problem. While using the delay block, there is some more options also which you can use. You can either use a user defined block, which is MATLAB function block, which you can use, or you can use a transfer function block in between to avoid this algebraic loop. So in place of this delay block, you can use a MATLAB function block, or which is a basically user defined block, and you can either use a transfer function block also. That will also help you to avoid the algebraic loop problem. So basically this is it, how you can solve the algebraic loop problem, and how you can also avoid it while creating your model. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. It will be more helpful for us to drive the topics in a proper way, and will give you a good insight into the topic. So happy learning MATLAB. Thank you and stay connected.